Nomenclature of alkenes is a relatively straightforward extension of nomenclature of alkanes with several important additional rules. And the first rule is that in order to get the name on an alkene, we're going to take the name of the corresponding alkane and then subtract this ane suffix and replace it with en. To illustrate this, the simplest alkene would be ethene, which in all the literature is sometimes referred to as ethylene. The next member of that class is propene, also known as propylene. And cyclic molecules such as this one will be known as cyclohexene. Okay. Now when we start looking at systematic nomenclature of alkenes, the first step that we need to undertake is to figure out the longest chain. But unlike in alkenes, now we have an additional requirement. We need to figure out the longest chain that contains both atoms of CC double bond. Okay? Let me illustrate this on an example. If you look at the molecule such as this pentene, then we will name this as a methylpentene. We'll worry about numbers later. And there is no ambiguity. There is clear what chain is the longest one. But if we have a possible ambiguity between a saturated long chain and an unsaturated long chain, we will always go for the unsaturated. So in this case, although we could go this way and get this curved saturated chain to be the longest one, we don't do that. This is the longest chain because it needs to contain both atoms of the CC bond, so we would name this as a propyl octene. Okay? So this is the first important difference. The second rule is that we indicate the position of double bond and assign it the lowest possible number. Now look at that, an example of this in a minute. So this will be 1, 2, 3, 4. So this will be 1 butene, not 3 butene, so, and also not 2 butene, because we started the first atom with double bond and we assigned it the lowest possible number. And we also start numbering the chain from the side, which is closer to the double bond. This molecule would be an isomer, and it will be 2-butene. And then molecules like this, again, cyclohexene. Ring systems don't have a beginning or an end, so that doesn't matter. Third step here is to add substituents. And we do that again as prefixes. This is fairly similar to the nomenclature of alkanes. But one thing that we must remember is that the double bond takes precedence. Because in alkenes, we didn't have any functional groups. The substituents themselves were the things of highest priority, and so they would take precedence when it comes to numbering. Here, substituents have to conform to whatever is already determined by the position of the double bond. So this will be 3-methyl 1-pentene. This molecule will be 3-methyl cyclohexene. Note that in the cyclic system we don't need to indicate the position of the double bond because it's understood. And for example, this molecule where we have a potential conflict, where we could envision a potential conflict in numbering, is decided now by the substituent, because it doesn't matter which side we start numbering from, we'll reach the double bond in position 3. So we name this as a 2-methyl 3-hexene. Okay. There are still further steps to go. So the step classified at D is to identify stereoisomers. And again, we could talk about trans or cis, and these are fine. We apply this in many cases. It's also worthwhile noting that most cyclic alkenes are always cis, because trans is too strained until we get to systems with 8 or more carbon atoms, and this is the trans cyclodecene. Okay, so this is an interesting feature, that trans alkenes are not stable. Trans cycloalkenes are not stable until CA. But this identification of stereoisomers is not quite complete here. What if we have a molecule that looks like this? It's not really clear if this cis or trans. It's not clear which two substituents we should look at. Okay, and so the cis-trans system is a bit ambiguous in cases where we don't have two identical pairs of substituents. And so in order to relieve us of that ambiguity, the EZ system of nomenclature was developed, which basically works so that you assign the higher priority group on both carbons. And you do this by using the same rules as in RS. So first molecular mass, then you move to double bonds, and so on. And so on this carbon, this will be highest priority substituent, this will be the second highest priority substituent, simply by virtue of molecular mass. Whereas on this carbon, this will be 1, and this will be 2. What we now see is that our two high priority substituents are on the opposite sides. And if they are on the opposite sides, they're classified as E, which comes from the German entgegen, which means opposite. If they're on the same side, then they will be classified as Z, which stands for German zusammen, which means together. And using easy nomenclature, we don't have to resort to cis and trans. Since this is a much more general system, it will apply to really any kind of a situation. To apply this on an example, here is a bit more complex molecule, and again here it wouldn't really be clear which two groups should we choose in our cis-trans notation as the bearers. But here it's clear, this is 1 on this carbon, this is 2, whereas here this is 1 and this is 2. And we look at this, and now we can finally name this as E, because of stereochemistry, 1-chloro, because of this chlorine substituent, 3-ethyl, 4-methyl, and again now we look at this as the longest chain, and these are substituents, 3-heptene, and this will be the full name of this molecule. Notice that every part of this name is completely indispensable. We cannot change any of this without modifying the molecule. There's some further intricacies of the nomenclature of alkenes. So if we have a system with 2 double bonds, that system will be called diene. An example would be, we number the double bonds again, so this would be 1,3-butadiene, whereas this would be 1,2-butadiene. This little dot in the middle signifies nothing else than a carbon atom. We just want to indicate it's there, and it's not just a single double bond. If we have 3 double bonds, then clearly the system would be a triene. We can go as far as we want to, but this system, for example, would be 1, 2, 3, 4, 5, 6. This would be 1, 3, 5 cycloheptatriene, and so on. In some cases, we don't even need to introduce this numbering too much, because some of these have really very common trivial names. So this is cyclopentadiene, although technically this will be 1,3-cyclopentadiene, It's often referred to simply as cyclopentadiene because of its great importance in inorganic and coordination chemistry. So, and finally, if we can, even though alkenes, so in this context, are never substituents, they're always part of the main chain. We'll see in later classes of compounds, when we have more complex molecules, that sometimes alkenes can really be a substituents. And so, in order to define alkenes as substituents, we again use the suffix, the name alkenyl, such as pentenyl or butenyl. But there are certain groups which have their trivial names, and this is the methylene group. Now notice that this group is divalent, okay, and it's not like a normal alkyl group which is monovalent. This has two valences, so this has this not just methyl but methylene, this whole suffix. This is a very common group which basically has just a double bond as a pendant to the main chain. This is the so-called vinyl group. It's a very common one. We've already seen when we talked about stabilities, this group, the allyl group, which is again often seen in many reactions, and so forth. So in other words, to sum this up, alkenes are named similarly to alkanes, but now we have a double bond which determines many things. First of all, double bond needs to be the part of the main chain. We number that chain starting from the side which is closer to the double bond, and then we position the substituents accordingly. Finally, the double bond has its stereochemistry, which in a simple fashion can be named simply as cis and trans. But if we want to be more comprehensive in general, we can use the EZ nomenclature, which is truly unambiguous in this case. And that's pretty much it as far as the nomenclature of alkenes. In the next topic, we will see what some common alkenes are used for in chemical industry.